Okay, good afternoon, everyone. Guten Tag. I know it's after lunch, I can appreciate it. I'll do my best to keep you entertained, and hopefully you'll learn something new from this presentation. It's called Automating Multi-Factor Authentication, when it should have actually been called Automating SMS and Phone Calls. And before we get into the actual automation part, I really want to say thanks to the Selenium conference organizing committee and White October events for the amazing job they did organizing this. This is my first Selenium conference, and I'm really excited to be here. And a huge shout out to Amanda at White Code Captioning for hopefully, she'll be able to deal with my accent. So let's get going. Really short slide about myself. I'm working as a research engineer at Forter. Forter is an e-commerce fraud prevention company. It's a startup company based in Tel Aviv. We are funded by Sequoia and NEA, which are two very large venture capitals from Silicon Valley. And what we do is we allow websites to stay protected from online fraud, online credit card fraud, and we provide them the best tools to stop the bad guys. I've been working in Forter for 2 years now, and the things I really had the chance to get into were mostly creating the Selenium infrastructure and Appium at Forter, and as well as creating the mobile SDKs for Android and iOS. So that's like my the main achievements I had while working at Forter, and that's how I got into the world of automation. I did meet Selenium before, but I've never used it in production the way that we are using it today. And just in general, I'm excited about mobile security, smart homes. I am organizing the Apple HomeKit meetup in Israel, as Andrew said. And down there is my blog address, if you need it. You can find the sources from these presentations in my GitHub, and there's a link in there. As I said about Forter, we provide decision as a service. That means that as a website, you're sending all the transaction details to us. Someone wants to buy a laptop, you're sending us all the details, and we'll tell you immediately in real time if to approve or decline this transaction, if this guy is a thief or not. And we provide 100% guarantee in case we were wrong, because in e-commerce, if you accepted a credit card transaction and it ended up being a fraud, you, as a website, has to return the money to the card owner. So the bank won't ask you, it just will take it back from your account and return it to the rightful owner. And I think it's funny I'm talking about automating multi-factor authentications, because in Forter, as a main thing in the beginning, we said, we're providing you full protection, and we're doing it automatically. You don't need to add barriers. You don't need to have verification of phone number using SMS. You don't need to have automated phone calls. Just send us all the details as is, and we'll take care of it. And obviously, the integration with us is backend, where you're sending all the transaction details, as well as adding our JavaScript or mobile SDK to your Apple website. And yeah, it all happens in real time, so it's a really cool project to work on. And I think the way we're doing development in Forter is pretty unique, because we don't have a QA team. We don't have a DevOps team. We have 25 developers, which are holding this company. We're 80 employees in the company, but only 25 developers. The rest are analysts that adjust our statistics model and contribute to the machine learning from the analytics side. And 25 developers are managing to write the code, deploy it, test it, automate it, monitor it, and provide real-time picture of what's going on in the system. And that's pretty cool. So no one in Forter is a QA engineer or automation engineer, but you have people who worked in this kind of role before, and you have people who got into those areas as they started working at Forter. You can ask me anything. We won't have time for Q&A, because I burned through 5 minutes of the 30 I got. So feel free to tweet me all your questions, and I'll do my best to answer it. As for the agenda, let's get talking. We're going to talk about what's multi-factor authentication, just real brief, and what it's good for, how can it help you, and how can it put sticks in your wheels when you're trying to go ahead and automate your flows, your websites or apps. And then we'll go to some very dangerous live demos. Nobody's going to get physically hurt, but I might get mentally hurt if I'm going to wreck the heck of those demos. So, and at the end, I'm going to show some points about the next generation of multi-factor authentication, what I think it's going to look like, and how should you prepare for it, because eventually we're going to have to test it too. So there are a few things this session won't give you and won't provide you. It won't make you neither telecom experts or security experts. It will introduce you to some basic ideas in telecom, and it will cover the security aspects of multi-factor authentication. And you won't leave this room with an end-to-end solution that is tailor-made for you, but you will have the tools to go home or office and do exactly what you want when it comes to automating telephony and SMS. And all the aspects of resource allocation, synchronization, forget about it. You have your own test suits, you know how to set up your environment, how to tear it down. I'm leaving it to you. All the demos here are, just basic stuff showing you how to get it done. Multi-factor authentication. Basically, it's a method that website developers, system engineers are using to make sure that only the rightful account owner, okay, whether it's an account in a Linux machine or whether it's an account in a website, only the rightful owner has access to that account. And the way to do that is by, moving from one factor, which is your password, it's something that you know, to having two separate factors that you need in order to get into your account. Okay? So what's going to happen is if you want to access, let's say, your Google account, you'll need to type in your password, which is something you know, and you will need to type in 6 digits code from the Google Authenticator app, which is something you have. You have your phone with the code in it. So these are two separate factors, and it basically makes it way, way harder for an attacker, for a hacker, to gain access to your account, because hacking your computer is a very complicated thing on its own, as well as acquiring your passwords or acquiring them from password managers, etc. But you do have things that happen, such as the Equifax data breach, where people's social security number, birth dates, previous used passwords are out in the wild, and a lot of people are taking advantage of it. And they're just, let's take this guy's birthday, let's take his SSN number, and just, try brute force our way into his account. And it works. It works a lot in many cases. And you do want to protect your system. This is absolutely important. It's either protecting your machines, and at Forda, when we are connecting to a production machine, we have, beside of having our SSH key, also type in multi-factor code. And that's like the next level of protecting your system. The common practices of doing it are few. You have 4-digit PIN code, which was used, for example, I think in United Airlines as application. This is not another factor. Have no doubt about it. This is just another password. It's the same as taking your long password and keeping it in 2 separate places. I've added all the pros and cons I could think of for all the methods we'll go through. I'm not going to get too much into the details. Feel free to go over the slides and take your notes. But the basic things are the additional factor has to be completely separate from the first factor. So as I said, if it's a password that you must have a physical additional factor, which is either your phone or a password manager that holds your constantly changing PIN code. But you need to separate those factors. Otherwise, it has absolutely no point. The next one, and this is, I think, today's most common practice, is SMS verification or automated phone call. And we're going to talk about how automating this flow completely today. So, for example, when you're logging into Amazon or Google or Facebook or Twitter, you name it, the service, if the service suspects, and what I mean by when I'm saying the service suspects is Google and Facebook are investing a lot of effort in preventing unprivileged people to gain access to your accounts. So what they're doing is they're putting machine learning into place, they're collecting data from the browser, and they're doing their best to determine if, now that you're logging from a new computer or a new browser at the same computer, if it is really you. And if you trigger an alarm, I'm sorry, if you trigger an alarm in their system, they'll probably ask you to provide the other factor, which would be sending you an SMS, having you type the code that you received, and go ahead. There is one major con to this method. And the very big downside of it is that your phone number can be hijacked. It has been proved before, it has been done before. You had companies in Eastern Europe that allowed, by utilizing a vulnerability in the cellular networks protocol, to hijack a phone number and receive copies of all the SMS messages that are sent to that phone number. You didn't have to do anything, you just have to be connected to one of the carrier's main switch, and you'll be able to do it from anywhere in the world, which is pretty amazing. And you have, especially in the US, a lot of stuff going on around hijacking cellular provider accounts. Someone will call to your provider and will say, hey, this is Or speaking. Someone stole my phone. I really need a new SIM card with the number right now because it's super urgent. And they'll say, OK, no problem. Just we can send it to you. You can go pick it up. And people are doing it. It sounds, why would you do that? But it happens. You have no idea what people will do in order to gain access to your Amazon account and start stealing the heck out of it. So the one major problem with SMS verification and phone calls is your number is not safe. Relying on phone number is not good enough. It's yesterday's technology. Authenticator apps and security tokens. I'm talking about actual physical security tokens. Like PayPal used to have this keychain you're holding, and it had 6-digit rotating code every 30 seconds. It's getting better, but once again, if someone stole it from you, okay, let's say your backpack was stolen and your keys were inside and an actual physical token was on it, or someone stole your phone, but your phone doesn't have the appropriate passcode complexity, then they can reuse it. If they have your password for your account, they can use the other token to gain access to your account. And it has its cons, obviously. This is an example to how modern authenticator apps look like. And as you can see, you have Okta on the left. Okta is a very common brand, a very new single sign-on provider. And single sign-on, it's called SSO. You can look it up. These are services that lets you, as a business, as an enterprise, use their service in order to log in to all of your systems. So Google has G Suite for Business. You can, my Forter Gmail account is an actual Google account, and I can log in with it to all the services in Forter. Google are providing the authentication, the sign-on. So they're the single sign-on provider. I have only to use them. Okta is promising the same thing, but they also offer you push notifications. They offered it before Google introduced the Google prompt, as far as I remember. So they had an advantage over it, and they also support things that Google are not supporting, such as using Okta as a password manager to log into your apps. These are just examples. I don't have any recommendation about either. And this is the last type of multi-factor authentication we're going to cover, at least deeply, and that's the protected one-time password. And what I mean when I'm saying protected one-time password is taking your password manager, such as 1Password or LastPass or whatever, you name it, and storing your one-time password token inside it. So Google Authenticator lets you basically scan a QR code, and you're receiving a secret key, which is used to generate your changing passwords. We'll see it in action in just a bit. And when you're taking this secret key, which is the second factor, is something you have, and you place it inside a password-protected password manager, sorry about the complexity of that, you have a second factor, which is protected by another factor. So that makes it 3 factors, hence multi-factor authentication. And I think this practice is much better than the alternatives we've just seen. And pros and cons, once again, if someone steals your password manager, stealing your phone, gaining access to it, I don't have anything else to offer. But modern password managers, especially those which are synced to the cloud, can be remotely shut and can be remotely re-encrypted, and you can always wipe your phone remotely. So this is, I think, the most protected method to do it. The last thing that we're going to just see the slide, I'm not going to talk about it at all. Voice biometrics. This is a practice that has become more and more common in banks. And banks, when I'm calling my bank and I want to make an order, what I mean by order, let's say I want to buy US dollars, and I want to do it over a phone call, then my automated system at the bank will say, hey, or please say the following phrase, Fuzzy Wuzzy was a bear. In Hebrew, obviously, because I'm from Tel Aviv. So I'll just say, Fuzzy Wuzzy was a bear, and then it say, OK, your voice is authenticated. Wonderful. We're transferring you to the attendant. And this is a very strong method, but I don't know. I don't know if anyone has automated it so far. I don't know how the authentication system in the bank is using, what system they're using, to do the biometrics. So, and we're also going to see Wi-Fi stuff going on, like, someone recording you talking for half an hour on stage and then generating all the notes you can make with your voice. So, but that's sci-fi. Yay, demos. I'm super nervous about it. As I said, that's gonna crash and burn, definitely. So I think we were talking about automating one-time password. I just lost my slide, but let's go with it. We have 3 methods to cover. One-time password, and I'm talking about Authenticator app generated. We have SMS reception for verification codes, and we have reception of phone calls. So we can go with the SMS because there's really nothing to show. What you're seeing is basically a webhook that I created. This is a text file that I'm using a webhook in a service called Twilio. I'll show a slide on how you get into it in just a second. And what happens is that I'm buying a virtual number, basically, buying or renting it for a certain period of time. And I'm just pointing this virtual number into a webhook. That allows me to receive SMS messages in no time. So what I'm going to do now is I'm going to use my phone to just text this number, and I'll say, hey, from SignOn, and if anyone wants to just throw random word into the room, so I'll type it in as well. Go ahead, Kasia. I'll call you Kasia Marks because obviously, I'm joking. So I've just texted to this number, and I'm going to hit refresh, and as you can see, I from SignOn, Kasia Marks. So that's it for receiving SMS. I'm going to show it's. If we can go back to the slides, that would be awesome. So this is SMS verification. Really nothing special to it. And this is how to do it. Go to a service that allows you to purchase a virtual number. They're called VoIP, voice over IP, wholesales. They allow you to purchase numbers in almost any country of the world. They allow you to receive SMS, receive MMS, and usually generate 4-digit phone numbers, like you have numbers starting with star. Twilio are known for being super friendly for developers and absolutely not friendly for the home user. So that's why I like using them. You basically go to twilio.com, you press phone numbers by a number, and then you point the phone number to your webhook. That's it. That's all it took to, and my webhook simply writes it into a text file. Enough with SMS. Let's go to time-based one-time password. So what you're going to see now is basically a Python script that I wrote. And it's available on GitHub already. You can go ahead and download it, or just review it with me. And what this script is going to do, it's going to log us into Facebook, to my Facebook account. Which is the stuff you shouldn't do automatically. I guess it's against the terms of service, but this presentation is for educational purposes, so I'm going to break a lot of terms of services. So Basic setup and teardown. What I'm doing with the setup is I'm creating a new instance of the PyOTP library. It's Python for time-based one-time password, or in general, one-time password. And what time-based one-time password does is it takes a secret key that you have, a shared key. Both you and the server side knows it. And according to the current timestamp, it generates a 6-digit code. And that's the way the Google Authenticator app works, as well as all the other alternatives. So I'm generating this time-based one-time password instance, and then I have a simple test case in which I'm going to facebook.com, filling in my username, password, hitting the login button, and then I'm basically locating the multi-factor authentication element and sending time-based one-time password.now, TOTP.now, as result into that field. And that's it. As you can see, it's really a stupid script that does that. I'm sorry. So what we're going to do is we're going to see my very embarrassing Facebook homepage. Facebook login. And yay. Hands up. This is username, password. Of course it crashed. I knew it. I should have made a slide for this one, because this one is like 10 times more simple than the alternative. So I'm going to do it one more time. I forgot to add the maximize window, which is obviously, this test is super flaky. And work. Yep, this is the one-time password. I'm saving the browser, and now I'm logged into my Facebook account. So that was the one. Yeah. If we can go back to the slide. This is the perfect time to take a water break. Okay. Now we're getting to the really interesting part, and this is automating phone calls. We're going to do that using a tool called Asterisk. Asterisk is an open source real-time communications engine. This is a very impressive title. And basically, it started in 1999 by a guy called Mark Spencer. He is the original creator of Pigeon, the Linux instant messaging client. And he decided he wants to be a Linux consultant in 1999, and he started selling his professional support services. And his business was going well, and he wanted to buy a PBX, so when personal phone exchange brands, whatever title that is. And what happened is that he reviewed all the PBXs available for sale in the market, and everyone wanted at least $4,000 for a simple PBX that you can connect two phone devices to the same phone line. And he was like, F that, I'm going to write it. And he wrote a full-blown PBX, all in C, and he put it on the internet. And this thing is the Selenium of the telephony world. So Mark Spencer is, the telephony fans' Simon, and everyone worships him and want to take a photo with him. And basically, what this wonderful engine lets you do is, using a very simple syntax, do whatever you want within phone calls. You can send, key presses to it. You can record it. You can hang it up. You can play music to it. And the internet went insane. This thing is installed by the millions all over the world. And I think it's great because it landed me my previous job. I made it a niche. I think I'm like the 5th or 6th person in Israel who actually kind of knew what he was doing with Asterisk, and that was cool. And we're going to use it today to automate not this kind of automation, okay? Because this is what Amazon asks you when you want to recover your one-time password to access your AWS account. They're saying, we're going to call you, and please, when you answer the phone, type in those 6 digits. It can be done with Asterisk. It can be done extremely easy, but I wanted to show the more common flow when the system calls you and reads out the code to you. So what you need in order to do that is have any kind of speech to text, any kind of transcribing API that will support that, and have an Asterisk machine, which all the source and all the examples are available in GitHub in order to do that. and afterwards just hook up the virtual phone number and run it, and it's gonna do exactly that. Let's demo, and let's hope this one's gonna do at least as good as the previous one. I'm not promising it's gonna work in the first try. Just before we do that, what I'm gonna do is against the terms of service. This time I'm gonna, heckle with Google. I'm gonna create a new Google account using a Selenium script, and I'm gonna authenticate and activate the account using my very own phone number. And what happens here is that there is this really stupid Selenium script that's called Google Register. It's available online. We're gonna enjoy the Chrome web driver in incognito mode that I'm using, and we're gonna use a class I wrote called gcloud transcript, which basically sends an audio file to Google for transcription and returns the results. And the rest here is blabber, is completely, just finding an element, putting stuff in, until it gets to the interesting part, where I am typing in the phone verification, press and click, and at this point, I'm stopping and observing to receive the recorded call. So what happens now, we're moving to the asterisk context, where I'm receiving the phone call, recording it to a file, and then just moving it back to the Selenium. So I'm running out of time. We're just gonna demo it, and either it's gonna work or not. So let's just check everything is in place. Yeah, we're connected. Second demo, phone calls, us. Yep. I'm using virtual env, which is a lifesaver, and Python, Google Register. Cross your fingers. Seriously, cross your fingers. I'm not joking. So this is up, and I'm just enlarging it and hands-free. I'm accepting the terms of service. It's not me. That's the Selenium does that. Okay, so it's his default. And as you can see, the phone call was answered right up there at the left corner, and the script is observing for an updated call record. And when the Google bot is going to finish reading the code out, the Selenium script is going to get that file and send it for transcription. So let's see it going on. Sorry about that. Super nervous. I have no idea why. And yep, it got the updated recording file. It's sending it to Google for transcription. And when it's going to get back, it's going to type in the code. If the transcription was OK, yeah, I knew it would happen. OK, so look. The code is, I got the code twice. I got it once as 5835 and at the end, and I got all the 6 digits here, and it's failing because it's not the same. I knew it would happen. So I just happened to save a nice video on my desktop called Kittens, OK? And that time, it did not fail. So yeah, Google are just so great at stopping fraud. This is like 100% fraud. So as you can see, you're
using Google's speech recognition
to create a Google account. Yeah. So this time it worked. You see that it got the code and it ran. I knew it would crash. I knew. This is working. I promise you, I can explain later why it's working. Just don't try it on Google because obviously they know what they're doing, and learn from them. If you could go back to the slides for the last minute I have. Whoop, that's not the right one. Yay, I knew it would crash. I knew it. I was ready for it. I have all the nice memes up there, and yeah, it worked. It worked. The next generation is going to be crazy. There are companies that can now authenticate you just by the way you're holding your phone in your hand. They read all the sensor data, and they can tell just by me doing that this is the real OR and let me in. And I want to thank you. This was so much to cover in 30 minutes. And if you have any questions, I'll be happy to answer them. And go to the GitHub. It's right up there. It's called Second Demos 2017. Everything is there. Just try to run it. And seriously, tweet me if you have any questions and you're having a hard time running it. But I hope this lets you the ability to get going in that area. So thank you very much.